Okay, so today we're going to be talking about the measures of spread and center, and then also moving into normal distribution. So it's kind of two lessons in one. This one's going to be a little bit longer of a video, and I apologize for that, but I'm just trying to get everything all organized before the end of the year. So the very first thing I'm going to talk about measures of center, or something called central tendency. We're dealing with data here, okay? So some data may contain hundreds or thousands of values, but oftentimes it can be summarized by one value representing the center of the data. Most often, you've heard of these very commonly. The three most common are mean, median, and mode, okay? The three M's. So the mean is also known as the arithmetic average. All right. Add up all the terms and divide by m, however many terms there are. So it's the sum of the terms divided by how many terms. Okay. The median is the middle number. All right. So when the data is organized from least to greatest or greatest to least, it's the one in the middle. And the mode is the most frequent, or the one that occurs the most times. Okay. But just knowing where the center of the data is isn't enough. We also need to know how spread out the data is. Okay, and so there are some ways to measure the spread of the data. The three most common for this one are the range, the interquartile range, and the standard deviation. Okay, so the range is the difference between the biggest and smallest values. Okay. The interquartile range, also known as IQR, that has to deal with quartiles. If I had more time, I would go through that with you. It's the difference from quartile 1 to quartile 3, basically the middle 50% of the data. Again, we're not going to worry about that too much. We're going to be focusing on something called standard deviation, which is to summarize it, it's the average of the differences between each value and the mean. There's actually a big long process to calculate it by hand. I'm not going to have you do that again. If we had time, I would, but we don't. So that's kind of what it is in a nutshell. Like I said, I wish I could be more thorough with this, but in the sake of saving time, we're not going to do that. So our first example, just finding the mean and the standard deviation of a very small set of data. So the mean and the standard deviation for these 5 numbers, 2, 5, 7, 8, and 10. Okay. Well, we all know how to find the mean, right? You add them all up and divide by how many there are. Okay, easy enough to do. You could do that one by hand. You could do that one in your head if you really wanted to. But what I'm going to do is I'm going to show you how to do it on your calculator. Now, if you don't have a graphing calculator, okay, on your Chromebooks, you can use an Excel document and put them in a list as well. Oops, my bad. Hold on a second. Okay, sorry, I had to clear my list there. All right, so if you do have a graphing calculator, you hit the stat button. Edit will bring you to the lists. You would just put these 5 numbers in your list there. Okay, so 2, enter 5, enter 7, enter 8, enter N. Okay, second quit gets you back to the home screen, and then you would go stat, over to calc, one variable stats. You might just have to hit enter for that one based on your calculator. Okay, and then it spits out a bunch of numbers to you. Okay, you can actually scroll up and down. That actually gives you your quartiles if you are interested in that. But I'm focused on what it first gives you. Okay, X bar, that's the mean. Okay, so the little X with the bar over the top of it, that's your mean. Okay, if you were to do this by hand, you'd end up with 6.4 as well. Okay, your standard deviation, okay, is the little sigma. It's a lowercase sigma x, and that in this case would be 2.73. You'd round it to the nearest hundredth. Okay, so it's this term down here. Okay, like I said, if you don't have a graphing calculator, what you have to do is in an Excel document, right? You have your cells or whatever. You would still, just like we did in the list there, you would still put in 2, 5, 7, 8, and 10. Okay, and then in any other cell, it doesn't matter. You would type in equals. Okay, and then you can do the command stdev period p, and then if you highlight these cells right here, for me that would be A1 to A5, it will actually spit out the standard deviation of this set of data. You can also do equals average of the same ones, A1 to A5, and it would give you the 6.4 for the mean. Okay, so you would have to use Excel. If you don't have a graphing calculator, that's fine, but you can still find a way to do it. If you have questions on that, let me know, because you do need to know how to do that. Okay, so that's mean and standard deviation. Now, moving into the next thing, which is called normal distribution. Okay, so a normal distribution is a bell-shaped set of data. It's symmetric about its mean. You've heard the bell curve, I'm sure. All right, so that's what a normal distribution looks like. It is symmetric about its mean. Technically, what I should be using here is mu, the Greek letter mu, if we're talking a population mean rather than a sample mean. But again, too technical for the purposes of this class, what we're trying to do. So in this case, I'm just using X bar, which is technically the sample mean, but okay, I'm getting off on it. Okay, so normal distribution, you've got 50% of your data below it, 50% of your data above it, but it gets more specific than that. Okay, there's something called the empirical rule, which states that within a certain number of standard deviations, a certain amount of data is occurring. Okay, so again, if we draw a little bell curve here, and we are symmetric about the mean, okay, so the mean's in the middle, within one standard deviation of the mean. Okay, so remember, standard deviation, it kind of tells you about how spread out the data is. Within one standard deviation each way, so plus 1 sigma and minus 1 sigma. Okay, between these two values here, you've got 68% of your data. Okay, which means that obviously what my drawing is not symmetrical, but it should be symmetrical. There's 34% of the data on this side and 34% of the data on this side. Okay, within 2 standard deviations of the mean. Okay, so from the mean, 1 standard deviation, 2 standard deviations above the mean, and 1, 2 below the mean. All right. If you were to gather all of that information there, you'd have 95% of your data. Okay. So again, if you do a little quick math here, 95 minus 68, you've got 27% of the data unaccounted for within these two little windows. And because it's symmetric, you divide that by 2, that means that there's 13.5% in this little branch and 13.5% in that little branch. Okay? within 3 standard deviations, okay, so 3 above and below the mean, you basically have it all. You have 99.7%. And again, the difference between the 99.7 and the 95 already accounted for would be the 4.7. And you divide that by 2 because you've got 2 equal sides. You've got, in this side, 2.35% and 2.35%. Okay, but that doesn't account for everything. There are extreme outliers that are more than 3 standard deviations one way or the other. Okay, if you think about it, we've got 99.7% of the data contained within these 3 standard deviations. That means there's 0.3% outside of 3 standard deviations, which means there's actually a little bit outside here. There's 0.15% on this side and 0.15% on this side. Okay, so that's the empirical rule. Have that in your notes because you're going to be referring to it a lot. Okay, so now let's actually do that. Let's refer to it. Let's see what we have here. Okay, suppose a pair of running shoes lasts an average of 450 miles with a standard deviation of 50 miles. Use the empirical rule to draw a normal distribution. Okay, so if this was on my whiteboard, I'd be fantastic at drawing bell curves. No promises with this one. Yeah, it's a good solid C- for that one. Okay, so we know in the middle you have 450 miles. That's the mean. That's the average. Okay, it says the standard deviation is 50 miles. So one standard deviation above the mean would be 500, 2 would be 550, and 3 would be 600. Okay, below the mean, you would just subtract 50 from your mean, so 400, 350, and 300. Okay, it's supposed to be super symmetrical. It's not, but okay. Anyway, find the probability that a new pair of shoes will have a lifespan between 400 and 500 miles. So if we look at this, 400 to 500 miles. Well, that's within 1 standard deviation, both above and below. Based on that empirical rule, what we just looked at, right? 1 standard deviation below and above, you've got 34 on each side. So that would be your 68%, okay? Because you've got 34 here and 34 here. Okay, part B, the probability that a new pair of shoes will have a lifespan more than 500 miles. Okay, so now we're talking all of this, okay? So on your little empirical chart here, you would go 1 standard deviation and above, and you would add all of those up. Okay, so you've got 13.5 plus 2.35 plus 0.15, that's 2.5, so 16%. Yeah. Okay, so again, just add up the percentages for your standard deviations, okay, and that's how you get a lot of these probabilities. Okay, one final question here. The resting heart rate of 9 students in beats per minute are shown below. Assume that the data is normally distributed. Find the mean and standard deviation of the data and draw a normal distribution. Okay, so again, this one, it doesn't tell us what the mean and standard deviation are, like it up here for this one. So we have to calculate that out first. Again, use a graphing calculator or that Excel document that I told you about. Okay, so again, you just put in the data, 63, 65, 60, 67, 66, 64, 63, and 74. Did I miss one? Or are there only 8? Okay, never mind. There's only 8 students here, not 9. All right. Okay, so it gives us our data that we want. The mean of this, okay, again, that's x bar, is 64 beats per minute. with a standard deviation of 4.64. Okay, and in fact, for this problem, 4.6 is good enough. Okay, so when we draw our normal distribution, okay, you draw your lovely little line, you draw your lovely little bell curve. Decent, I guess. Okay, in the middle is your 64 beats per minute. Okay, you need to draw 1, 2, and 3 standard deviations above, 1, 2, and 3 below, and then you have to add your 4.6 to your 64 for each of these ones above. So that would be 68.6. Okay, and then you add another 4.6, so 73.2 and 77.8. Okay, going the other way, you just subtract 4.6 from 64. So that would be 59.4, 54.8, and then 50.2. Okay, so those would be the values that you would have for each of your standard deviations above and below the mean. There's not a follow-up question here, but you see how you would actually draw that out. Okay, these percentages work for normally distributed data. In the next lesson, we're going to talk about what happens if you don't exactly fall on one of the standard deviations. But for right now, that should get you started.